Okay guys, so I just wanted to record a difference of squares lesson. So this is a type of factoring. It's actually one of the easier types of factoring, but unfortunately one of the most easily forgotten types of factoring as well. So a really quick recall from some of the stuff that we've done before this unit regarding special products, that when we take a FOIL question using the same last term, so using the same 3 here, but with opposite signs, so one of them has a plus and one of them has a minus, we actually wind up getting a binomial. And that binomial is there because that middle term winds up getting canceled out, right? So if I did x times x, I get x squared. If I do x times 3, I get positive 3x. If I do negative 3x times negative 3x, I wind up with negative 3x. And if I do 3 times 3, negative 3 times positive 3, sorry, I get negative 9. So those two middle terms winds up canceling out, and I get that result as a binomial. And the same principle works for pretty much any one of these. You can see again that this one and this one are essentially the same with the exception of their middle term. They do actually expand to be that. You'll notice, okay, that both of these terms, the first one and the last one, are what we call perfect squares. They are square rootable, I guess, is the best way to put it. And that the operation that's in the middle is subtraction. So we call this a difference of squares because, again, we're subtracting two perfect squares. So this is a super easy type of factoring because all we have to do is detect that it's a difference of squares and write down our answer. Okay, so first of all, the detection process here is that we've got x squared, which is a perfect square, right? The square root of x squared is x. Then we've got a perfect square, which is 9. The square root of 9 is 3. So all we have to do is set up our brackets because we know it was a FOIL question in the first place. The first term is the square root of the first, so the square root of x is x. The last term is the square root of the last term, which is 3. And we just have to remember this little trick because it's a difference of squares. One of them is plus and one of them is minus. Now the order that you write plus and minus does not matter at all, okay? And the same thing goes for the example that we just saw above. You know, the square root of that is actually going to be 4x, and the square root of that is going to be 9. So one of them is going to be a plus, and one of them, as I run out of space here, is going to be a minus. Okay? So, a few little notes about factoring a difference of squares. We just take basically the square root of things. So in order for us to take the square root, they have to be square rootable. So the detection, as I said, is the key. Okay? The product and sum and difference of squares would be 0. So again, you could use that product and sum thing. So basically, if we went back to the first example, we could say it has a product of negative 9. We could say it has a sum of 0 because there's no middle term, right? There's no x term. Those two numbers are positive 3 and negative 3. And for this one over here, if you wanted to, I guess you could do decomposition, but that's going to take you a while, so probably not worth doing. Okay, so difference of squares is the key to remember. Okay, so I will give you a bit of a large hint here. All 5 of these examples are actually difference of squares. They are all perfect squares being subtracted one another. Okay, so they are all difference of squares. X squared, again, the square root of x squared is x. 49, the square root is 7. One of them is a plus, one of them is a minus. Really super easy. So here's my hint. I want you to pause the video now. Go ahead, write down B, C, D. Go ahead and try them. Don't worry about E unless you're really, really gutsy. I want you to pause the video and I'll put down the answers. All right, so question B, you're going to wind up with, I'll do it in a different color, 5x minus 8y and 5x plus 8y. And you'll notice it doesn't have to be plus first, it doesn't have to be minus first. As I run out of space here, we just try and make that a little bit smaller so it's out of our way. You'll notice that with question C, they're not perfect squares. Well, I didn't lie to you. There is a common factor that can be taken out of them. 2x squared minus, what's 72 divided by 2? 36. And you'll notice that now the stuff that's inside of the brackets is a difference of squares, right? So plus 6 minus 6. Okay. Finally, the last example, those are perfect squares. You just have to be careful with that x to the power of 4. The square root of x to the power of 4 is x squared. So that works out to be x squared minus 9 and x squared plus 9. Now, I would stop right there and be very careful, okay, because we're not quite done factoring. We haven't factored fully. If you look really closely, this first binomial is actually a difference of squares inside of a difference of squares, right? So kind of like that movie Inception where there's a dream inside of a dream. Here we've got difference of squares inside of a difference of squares. So be careful with that. We're not completely done with this question. So this one actually works out to be 2x minus 3, 2x plus 3. We get that from this guy here. And we basically just copy that down because that I've just underlined in blue is not a difference of squares, right? Because it's not a difference. It's got a plus sign there, right? So that we can't really factor it as a difference of squares, and we can't really factor it any further. So it stays as it is. Question E is a little bit tricky because we're dealing with fractions, but realistically, again, nothing changes. We just want to take square roots of things. So the square root of that first term is going to be a over 4, and the square root of that second thing is going to be 5 over 9. Oops, sorry. Because the square root of 25 is 5 and the square root of 8 is 9. If you don't trust that, you can probably grab a calculator and take a look-see. That's going to be a plus, and that's going to be a minus. All right, so hopefully that takes care of difference of squares. Really, really easy process, a lot faster than most of the different types of factoring we've been talking about recently, okay? The only time this is going to get super complicated is when we need to use substitution. So sometimes when we're asked to factor, we get really complex things that do look like difference of squares, but there's like monomial or binomials in some cases and trinomials even in some cases. So the examples will actually give us a hand here. So with question A, let me just space these out a little bit better. But with question A, we've got x plus 3 squared minus 4y squared. So in theory, x plus 3 squared is a perfect square because, well, it's squared, right? We know that the square root is the opposite of squaring. So, the square root of x plus 3 would just be x plus 3, right? Or, sorry, x plus 3 squared would be just x plus 3. So what we do is we say let x plus 3, let A represent x plus 3, sorry. Let A represent x plus 3. So we're going to use the letter A to represent it. So we're going to rewrite it as a squared minus 4y squared. That now is a little bit of an easier difference of squares to deal with. Okay, you don't necessarily have to use substitution like that, but it does make it a little bit easier because now we can square root a squared a lot easier, right? Square root of a squared is just a minus y, a plus 2y. And now we resubstitute back in, right? So we said in the beginning that x plus 3 was a, so we write x plus 3 where we see an a. This is a y. X plus 3 plus 2y. We wind up with a trinomial multiplied by a trinomial, right? There are no more like terms inside those sets of brackets. Okay? So what happens with question B is we probably want to have two variables, one for that first binomial and one for that second binomial. So let's have two let statements. Let A represent 7x plus 2, and let B represent 4x minus 3. So this is very simple. If we do that substitution as a squared minus b squared. And we remember that from the first bit of the lesson, that is a difference of squares. A plus b, a minus b. Now all we have to do is write some substitution in here. So a is 7x plus 2. Right, that's a. And b, we're going to add b, is 4x minus 3. You'll notice that I'm kind of overusing brackets here, and that actually is important because of this second binomial because we're subtracting. Okay? Because remember, subtraction is kind of like distributive property. So for A, we've got 7x plus 2. We're going to subtract B, which is 4x minus 3. And close that last bracket. So this is a mess of brackets, slowly. kind of popping up, but as we continue, I'll draw a little bit of a dividing line between those two questions. As we continue, we're going to collect some like terms here, right? So when we're adding, nothing really changes, right? So we're going to take 7x and we're going to add 4x, which is 11x. We're going to take 2 and we're going to add negative 3, which is just the same thing as subtracting, but adding a negative is the same thing as subtracting, so we wind up with negative 1, 11x minus 1. The second set of brackets, if we go ahead and take a look here, we've got 7x minus 4x. That gives us 3x. And we've got to be really careful here because 2 minus negative 3 is the same thing as 2 plus 3. And 2 plus 3 is 5. Right, so that winds up being the answer to that. So certainly this is a factored form of that. That original question, B wasn't in factored form because you had the minus in the middle. Now that we're at the bottom here, that works out to be the final incorrect answer. So hopefully that's a really quick 10-minute brief as to what was included there. You can see the homework is posted on the course website for tonight. Please complete that stuff from the textbook. Thank you.